Hello students, as a part of our series Mathematics for High School Physics, from this class onwards we are going to discuss basic calculus. As I said, there are three parts in the course Mathematics for High School Physics that we are going to discuss. The first part is trigonometry. We discussed trigonometry, and the second part is basic calculus. Well, calculus is one of the most important mathematical concepts required to understand physics. Here, we are not going to study calculus in a traditional sense, like mathematics students study calculus. We are going to study calculus. We are going to discuss calculus in a way that is required to understand physics. So, what do we study in calculus? Calculus is of two parts. Basically of two parts. One is differential calculus and the other one is integral calculus. So we have differential calculus and integral calculus. We are not going to have extensive discussion of calculus. We are only going to discuss calculus up to whatever is required to understand 11th and 12th class physics. What do we do in differential calculus? I can say, if I have to put it in one sentence, we study rate of change in differential calculus. Rate of change of one physical quantity when another physical quantity changes. In mathematics you call variables, but in physics the variables are nothing but physical quantities. So when a physical quantity x changes, physical quantity y also changes, if y depends on x. We are going to study how y changes as x changes in differential calculus. So we are going to deal with changes in y and changes in x, or changes in any other physical quantity. We are going to deal with changes in different physical quantities in differential calculus, different variables. Delta indicates the change. Delta x is change in x. Delta y is change in y. Delta indicates the change of any amount. There is no specific limit for this change. Delta x indicates change in x, delta y indicates change in y, delta indicates the change in x and change in y. Well, here we are interested in differential calculus, we are interested in small changes. In x and small changes in y, small changes in any other physical quantities. We are interested in small changes here. Small changes are denoted by d, not delta. Delta is the symbol used for change, any amount of change, maybe significant amount of change, considerable amount of change. D is a small change. You can say D means a little bit of. The meaning of D. D is not a variable here. D is not a physical quantity. Okay, D is a symbol used for small change or a little bit of change. Dx means a little bit of x. Or a little bit of change in x. A little bit of change in x is dx. Similarly, dy is a little bit of change in y. Well, so that's what we study in differential calculus. We are going to study rate of change in one physical quantity with respect to another physical quantity. If we have to put broadly what is differential calculus about? We can say we study rate of change in differential calculus. Okay, so we study dy, dx, small changes in x, small changes in y, how small changes in effect, the effect changes in y, how small changes in effect, x effect changes in y, that we are going to study in differential calculus. What we are going to do in integral calculus is integration. Integration means addition, summation. Simply putting, integration means addition. So what are we going to do in integral calculus? We are going to add these little bits of x or little bits of y. That addition, the summation of little bits of a physical quantity is called integration. So summation of all little bits of x is what we are going to study in integral calculus. This symbol stretched s, letter s, if you stretch it up and below, this symbol is used for integration. Integral dx means sum of little bits of x, sum of small values of x. That's what we are going to study in integral calculus. Okay. Now, before we actually enter differential calculus, let's try to understand what rate of change means. How physical quantities depend on one another. How do we study rate of change in physical quantities? Okay. You know, physical quantities are interdependent in physics. You can say if your body is moving, displacement changes with time. If your body is in uniform motion, or if your body is in uniformly accelerated motion, if at all a body is moving, with time displacement is changing. Unless a body is at rest, displacement changes with time. And sometimes, for example, in uniformly accelerated motion, velocity changes with time. I write velocity as a function of time. What it means is velocity depends on time. Velocity changes as time changes. This is how mathematically we represent the dependence of velocity on time. Okay. Similarly, in the atmosphere, as you go above, what happens to pressure? Pressure changes with height. So we can say atmospheric pressure on the surface of Earth is a function of height because it changes as height changes. So like this, physical quantities are interdependent. Physical quantities change as some other physical quantities change because they depend on one another. For example, if you take one more example, gravitational force between two particles of masses m1 and m2 depend on masses of the two particles and also separation between the two particles. Like this, many physical quantities are interdependent. So they vary. When one physical quantity varies, a physical quantity depending on that physical quantity also varies. So in general, we can write y as a function of x. Let us say x and y are two variables mathematically speaking. In physics, they are two physical quantities. Okay, let us say there is a physical quantity y that depends on x. So this is how we mathematically write y is a function of x. It simply means y depends on x. Okay, so what type of relation is there between x and y? This is a function. What type of function is this? It depends on physical quantities, it depends on physical situations. How y is changing as x is changing is given by different varieties of functions. You know, in different functions, y depends on x in different ways. The relation between x and y is different in different cases. Okay, here we are just saying y is related to x. We are just saying y is changing as x is changing. But at what rate y is changing as x is changing? how are x and y related are given by different varieties of functions. In mathematics, there are varieties of functions. It could be a sinusoidal function, it could be a sine function, it could be any trigonometric function, it could be a logarithmic function. Okay, so there are varieties of ways in which y changes as x changes. In other words, there is varieties of functions in mathematics. Let's write down different varieties of functions here. You can have polynomial functions. You study polynomials in 9th and 10th standards. Polynomial functions. You also have algebraic functions, linear function, quadratic equation, etc. If I have to write, there are trigonometric functions. And inverse trigonometric functions. You will know what inverse trigonometric functions means later. Logarithmic functions. And exponential function. These are some of the varieties of functions that we come across. Okay. So when we say y is a function of x, y may be equal to 2x. This is a function in which y is related to x. This is another function. The relation between x and y is now different. Y is equal to x square is a relation between x and y, different from here. Y is equal to log x, base e, natural log x. This is another function. Y may be equal to sin x. This is another function. Like this, you can have number of varieties of functions in which y changes as x changes. Well, here, let us take a function and let's understand what rate of change means. We said differential calculus is all about rate of change. So let's try to understand what rate of change here means. Okay. So in differential calculus, we are going to understand rate of change. Differential calculus is all about rate of change. That's what I said. Let's take a function, any function. It could be algebraic function, trigonometric function, logarithmic function. Take whatever the function you like. Let's say y is a function of x. Y changes when x changes. That's what it simply means. Y changes when x changes. At x is equal to x1, let us say y is equal to y1, or you can write y is equal to f of x1, y1 is equal to f of x1. At x is equal to x2, when the value of x changes, x1 and x2 are two different values. Now y2 is equal to f of x2. So when x goes to a different value, when x changes to a different value, y also changes to a different value. Here change in x is denoted by delta x. Delta indicates the change. Change in x is from x1 to x2. X has changed from x1 to x2. So x2 minus x1 is change in x. Change in y is of course y2 minus y1, or we can write f of x2 minus f of x1. Now what do we mean by rate of change? Rate of change in y rate of change in y with respect to x. Rate means per unit, that's what it simply means. Rate of change in y with respect to x means, it means change in y per unit change in x. To put it in a simple language, when change 1 unit, when x changes by 1 unit, then the change in y when change in x is 1 unit, then the change in y is called rate of change in y with respect to x, is called rate of change in y with respect to x. So rate means per unit. Well, if you go to a shop and if you want to buy a pen and if you ask rate, the shopkeeper tells you cost of 1 pen, right? The cost of 1 unit, rate. In economic terms, rate means cost of 1 unit. Similarly here, rate of change in y with respect to x means change in x. So when change in x is 1 unit, then the change in y is called rate of change in y with respect to x. I'll give you an example. If you, let's take an example. You buy 10 pens for 100 rupees, let's say. What is the rate? Rate here means cost of 1 pen. So rate is 100 by 10, which is equal to 10 rupees. So 10 rupees is the rate at which you bought 1 pen. So we call it rate. Similarly here, rate of change in y with respect to x means, let us say change in y is 10 units when change in x is, let's say, 5 units. Change in y is 10 units when change in x is 5 units. So when x changes by 5 units, y changes by 10 units. That's what it means. So here, what is the rate of change in y with respect to x? It means when change in x is 1 unit, what would be the rate of change? What would be the change in y? So change in y per unit change in x. For 5 units change in x, change in y is 10 units. For 1 unit change in x, change in y is 10 by 5. For 1 unit change in x, change in y is 10 by 5. So 10 by 5 is equal to 2 is the rate of change in y with respect to x. So this is delta y by delta x. So delta y by delta x is the rate of change in y with respect to x. It's very simple. When change in x is 5 units, change in y is 10 units. When change in x is 1 unit, what is the change in y? 10 by 5. It's like 10 pens cost 100 rupees. What is the cost of 1 pen? What is the rate at which pens are bought? 100 by 10. Similarly, when change in x is units, when change in x is 1 unit, then that is respect to x. Okay. So rate of change in y with respect to x means change in y per unit change in x. That's what it means. Let's see a few examples here by taking some functions. Let's take a function y is equal to 4x. Very simple function. This is called a linear function. First degree polynomial. Y is equal to 4x. Now, let's take the values of x changing from maybe from 2 to 4. Okay, you can take any range of values. Delta x is equal to, let's say, x changes from x1 is equal to 1 unit to x2 is equal to 3 units. Then y changes from y1 is equal to, substitute x1, you will get y1. So y1 is equal to how much? 4. 2. y2 is equal to, substitute x2, you will get y2. Substitute x2, you will get y2. How much do you get y2? Equal to 12. 4 into 3. y2 is equal to 4x2. 4 into 3 is equal to 12. So y changes from y1 to y2. So what is delta x here equal to? Delta x is equal to 3 minus 1. Delta x is equal to 2. And what is delta y here is equal to? Y2 minus y1, that is 12 minus 4. So change in y is equal to 8. So how much is change in y when change in x is 1 unit? For 1 unit change in x, for 1 unit change in x, y changes by delta y by delta x, which is 8 by 2. Y changes by 4 units. That's what it simply means. So this is called rate of change in y with respect to x. So here, rate of change in y with respect to x. Rate of change in y with respect to x is equal to 4 units. That's what we would say. Rate of change in y with respect to x is 4 units in this interval. And x is changing from 1 to 3. In that interval, this is the rate at which y is changing with respect to x. So in the interval, from x is equal to 1 to x is equal to 3, we would say delta y by delta x, or the rate of change in y with respect to x, to 4 units. Now change the interval and find out delta y by delta x again. Change the interval again, find out delta y by delta x again. If you do that, you will always get 4 units for this function. For the function we have taken y is equal to 4x. For any interval, change the interval from 1 to 1.1, or take the interval from 2 to 2.2. Take any interval, any values of x you like. Okay, change x from any value to any other value that you like. You will always get 4 units in this case. Let's see why. Let's write down generally how do we find delta y by delta x in this case instead of taking the values. You know, y1 is equal to 4x1 and y2 is equal to 4x2. y2 minus y1 is equal to 4x2 minus 4x1. y2 minus y1 is delta y. Take 4 common on the right side of the equation, you will get delta x. So delta y by delta x, in any interval you are getting delta y by delta x always equals to 4. We can also write it in another way. Suppose we have function y is equal to 4x. Here y is equal to 4x is the function we have. When x changes, when x changes to x plus delta x, y changes to y plus delta y. So in that case, you can also write this as y plus delta y is equal to 4 times x plus delta x. Simplify this, you will get y plus delta y is equal to 4x plus 4 delta x. Okay, 4x and y get cancelled. You will get delta y is equal to 4 delta x. Take delta x to the left hand side of the equation, you will get delta y by delta x is equal to 4. Okay, so this way also you can find rate of change in y with respect to x. This is a simple example of this function is one of the simplest functions that we can take to find rate of change. I'll take one more. Let's take y is equal to x square. Using this function, let's also enter what differential calculus means, how we are going to study little bits of changes in differential calculus. Let's take y is equal to x square function. If we take y is equal to x square function, when x changes to x plus delta x, okay, instead of taking the values, ranges, let's generally find out what delta y by delta x is. Let's get the generalized expression of rate of change in y with respect to change in x. Okay, so if x changes from x to x plus delta x, y changes from y to y plus delta y. If y is equal to x square, y plus delta y is equal to x plus delta x whole square. Expand the right hand side down. If you expand it using a plus b whole square formula, you will get x square plus 2x delta x plus delta x whole square. You know y is equal to x square. Y and x square get cancelled because y is equal to x square. There is a mistake here. This is delta y plus delta y. Okay. So y and x square get cancelled. You will get delta y is equal to, take delta x common on the right hand side. Take delta x out. Would you have inside 2x in the first term and delta x in the second term. Okay. So here, take delta x to the left hand side. You will get delta y by delta x is equal to 2x plus delta x. So the rate of change in y with respect to x, in the previous case, we got a constant value for this function. When you found the rate of change in y with respect to x, we got it 4. For any interval, for any values of x, if you find delta y by delta x, you will get always 4. In this case, in the case of this function. But here, delta y by delta x, that is the rate of change in y with respect to x, depends on x and the change in x. It depends on x, that is initial value of x. It also depends on the interval, that is change in x. Let's say some numbers, some examples. If x changes from four to 5. X value changes from 4 to 5. So take x is equal to 4 and delta x is equal to 1 unit. Change in x is from 4 to 5. Change in x is equal to 1 unit. So substitute x is equal to 4 and delta x is equal to 1 in this equation. You will get delta y by delta x is equal to 2 into 4 plus 1. So what are we getting? 9. So in the interval from x is equal to 4 to 5, in this range of values of x, if we find delta y by delta x, we are getting 9. Take different values for x, different interval, you will get different value for rate of change in y with respect to x. Delta y by delta x value will be different, of course, because it depends on x and also the range, that is change in x.